Okay, so today we're going to learn how to use the sum and difference formulas. And we use the sum and difference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. Before we get started using the formulas, I would like to show them to you. They are on your math chart, so you can look at them on your math chart. On the right hand side of your chart, the last column on the right there, you'll see them. They're called the sum and difference formulas. And it starts with the sine of alpha plus beta. And so we're starting here with sine alpha plus beta. These are two angles, and we're adding them together. And we're finding the sine of these two angles added together. So when we have a sine with two angles added together, we're going to use this formula. Sine of alpha, cosine of beta, plus or minus cosine alpha sine beta. So the plus or minus depends on how we started. If we started with a plus, then we're going to have a plus between our formula. If we started with a minus, if this was a subtraction, then we would have a subtraction over here. With the cosine is different though. With cosine, we also have two angles, alpha and beta. So cosine of alpha plus beta would be cosine alpha cosine beta minus sine alpha sine beta. So the operation changes from addition to subtraction. If we subtracted, we would have cosine alpha minus beta, cosine alpha cosine beta plus cosine alpha sine beta. So it just kind of depends on what we need, which formula we need. That will determine which one we're going to use. All right, so the last one is tangent. If we have a tangent of two angles added together or subtracted, tangent alpha plus or minus beta, we're going to use tangent alpha plus or minus tangent beta divided by 1. And then if we added first here, we're going to subtract first here, tangent alpha, tangent beta. Or we have tangent alpha minus tangent beta over 1 plus tangent alpha, tangent beta. So this looks like a lot of formulas, but you don't have to memorize them. They're on your formula chart. We're just going to use these formulas to help us evaluate, verify, and solve. All right, so let's take a look at our first example. It says, find the exact value of cosine 75. Well, we don't have 75 as one of our values on our unit circle, but we do have two values on our unit circle that will add to give us 75. Do you know what they are? They are cosine of 30 degrees plus 45 degrees. So we're going to use our cosine alpha plus beta formula. Okay, we're going to use this formula right here, cosine alpha plus beta. This is the one we're going to use. So we're going to do cosine alpha cosine beta minus sine alpha sine beta. So let's go ahead and write that down. All right, so we have cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees times sine of 45 degrees. So what we're going to do now is we're going to look at our unit circle. We're going to find these angle measurements, or the side measurements that go with these angles, and we're going to put them down and multiply them together. Okay, so the cosine of 30 degrees is root 3 over 2. The cosine of 45 degrees is root 2 over 2, minus the sine of 30 degrees, which is 1/2, times the sine of 45 degrees, which is root 2 over 2. We're going to multiply these together and simplify, and what we get in the end will be our answer. All right, so we multiply root 3 times root 2, and we get root 6. minus 1 times root 2 is root 2, all over our common denominator of 2. And this is the answer for our evaluation for this degree of cosine 75 degrees. Okay, in the next example, we need to find the exact value of sine of pi over 12. Well, we don't have a pi over 12 on our unit circle, but we do have some values on our unit circle that we can add or subtract to get pi over 12. So let's take a look at really quick here. Take a look at your unit circle in quadrant 1. Okay, so what I've done here is I've taken our common angles, pi over 6, pi over 4, pi over 6, pi over 4, and pi over 3, and I've converted them into angle measurements with a denominator of 12, because here we have sine of pi over 12. So what we're trying to do is we're trying to get to pi over 12 with two of the angles that we already have. Well, here we have pi over 6, which is the same thing as 2 pi over 12. We have pi over 4, which is the same thing as 3 pi over 12. And we have pi over 3, which is the same thing as 4 pi over 12. All right, so which of these angles could we use to get to pi over 12? Well, I could subtract 4 pi over 12 minus 3 pi over 12. That would get me pi over 12. So let's go ahead and use that. We're going to use this one and this one. So let's go ahead and write those down. Okay, so we can write this sine of pi over 12. We can write it as 4 pi over 12 minus 3 pi over 12. Another way we can write this is using our original angle measurements, pi over 3 minus pi over 4. Now, if I had originally written it down this way, you wouldn't recognize it, I don't think, as pi over 12. I had to convert this to 4 pi over 12 minus 3 pi over 12 so that you could see that indeed these two subtracted from each other equals pi over 12. So pi over 3 minus pi over 4 equals pi over 12. Now we're going to use the formula to help find the exact value. Okay, so here we have sine of alpha, which is sine of pi over 3, cosine beta, which is cosine pi over 4, minus cosine of alpha, cosine of pi over 3, times sine of beta, sine of pi over 4. So we're going to find these exact values, and then we're going to simplify. All right, so using our unit circle, we see that sine of pi over 3 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. And since we're using the sine formula and we're subtracting, we're also going to subtract here. And then we have cosine of pi over 3, which is 1/2, times the sine of pi over 4, which is root 2 over 2. We're going to multiply these together and simplify and come up with our final value for sine of pi over 12. Okay, so multiplying root 3 times root 2, we get root 6, minus 1 times root 2 is root 2, all that over our common denominator of 2. And that's our final answer for the sine of pi over 12. Okay, so here we have an example 3. Find the exact value of sine of 42 degrees cosine 12 minus cosine 42 degrees sine 12. So which formula does this look like? Go ahead and look at your formula chart and write down the formula you think this most closely resembles. Okay, it looks like sine of alpha minus beta. So really, to find the exact value of this, all we need to do is subtract these angles. So 42 degrees minus 12 degrees is 30 degrees. So really what we're looking for is the sine of 30 degrees, which equals 1/2. Okay, let's do one more example. This one is not in your notes, but I would like to do an example of a tangent so that we can practice with the tangent formula as well. So let's find the exact value of tangent of 15 degrees. What two angles do we have in quadrant 1 or any of the other quadrants? It doesn't matter, but since 15 is a small degree measure, let's stick with quadrant 1. What two angles do we have in quadrant 1 that will add or subtract to give us 15 degrees? Well, 15 degrees is a small number, so we're probably going to have to subtract. And I'm going to assume that we probably should use 45 and 30. What do you think? Okay, so using our tangent formula, we have tangent of 45 degrees minus tangent of 30 degrees, that'll give us tangent of 15, divided by 1 plus tangent of 45 degrees times tangent of 30 degrees. So when we find these values and simplify, we will get the exact value for the tangent of 15 degrees. Okay, so we have 1 minus root 3 over 3 over 1 plus root 3 over 3. Now we have to simplify this. Here you can see I've changed my 1's to 3 over 3, so we have a common denominator and we can combine these. Same thing down here with the denominator. So let's go ahead and combine this numerator and this denominator and then see what we get. Okay, so when I multiply by the reciprocal, these 3's are going to cancel out. And what I have left is 3 minus root 3 over 3 plus root 3. And that is going to be my exact value for the tangent of 15 degrees. And there you have it. Now let's try some practice problems. I'm going to put some problems up on the board for you to practice. And I would like for you to practice at least one of each kind of formula that we looked at today. And then we'll continue these on Monday.